In this video, we are going to evaluate integration of log of sin x dx. So here I start with let I be integral from 0 to pi by 2 log of sin x dx. Let this be equation number 1. Now in next step, I can write I is integral from 0 to pi by 2 log of sin of pi by 2 minus x dx. Now what I have done here? So here I have applied a property from definite integration, and that is integration of f of x dx for limits a to b can be written as integration of f of a plus b minus x dx from a to b. So if you observe, this is a plus b, that means these limits I have added. So 0 plus pi by 2 becomes pi by 2. It becomes log of sin of pi by 2 minus x dx. So in next step, one can write this as I is equal to integral from 0 to pi by 2. It is log of cos x dx. Let this be 2. Now if somebody asks to derive integration of or to evaluate integration of log of cos x dx from 0 to pi by 2, it is exactly same as integration of log of sin x dx from 0 to pi by 2. So both are same. Now look at next step. In next step, I am adding equations 1 and 2. So what I can write on left hand side is 2y and right hand side is integral from 0 to pi by 2. It is log of sin x plus log of cos x dx. Now what to do next? In logarithms, there was property, and property was log of m plus log of n. So what was log of m plus log of n? It can be written as log of mn. So in the integral, I can write it as log of sin x into cos x dx. The limits are from 0 to pi by 2. Now what next I can do? In next step, I can write this as 2i is equal to integral from 0 to pi by 2. It's log of 2 sin x cos x upon 2 dx. That is, it can be written as integral from 0 to pi by 2 log of. Now what is 2 sin x cos x? It is simply sin 2x. So it becomes log of sin 2x upon 2 dx. Now what we can do in next step? In next step, again with reference to the property of logarithm, I can write 2i as integral from 0 to pi by 2. It's log of sin 2x minus log of 2 dx. Now here the property I used is log of m by n is log of m minus log of n. This is the property we used here. Now in next step, I would like to write then this one as integral from 0 to pi by 2 log of sin 2x dx minus integral from 0 to pi by 2 log 2 dx. So I've separated them into different integrals. Now in next step, for this first integral, I'm going to use the substitution which is 2x bt. If 2x is t, then one can write 2 dx is dt. And in next step, dx can be written as dt upon 2. By the way, since x tends to 0, now I am changing the limits. For lower limit, it is 0. Since x tends to 0, one can write t also tends to 0. And if x tends to pi by 2, this is upper limit, t can be written as pi. Now what we can write for 2i then? The 2i can be written as, now for lower limit it's 0 only and upper limit is pi. So integration from 0 to pi of log of sine t into dt by 2 minus. For the second integral, I have taken log of 2 outside the integral. It is from 0 to pi by 2 integration of 1 dx. Now what to do further? In next step, what I can write for the first integral is 2i is half of this 1 by 2 I have taken outside the integral. And then this limits, if you observe, I have changed a bit. It is 0 to pi by 2 log of sine t plus log of sine of pi minus t dt minus, here it's for the second integral, it's simply log of 2 into integration of 1 is x from 0 to pi by 2. By the way, what I have applied for this case? So for this case, I have applied integration from 0 to 2a f of x dx can be written as integration from 0 to a f of x plus f of 2a minus x dx. This is again one of the property from definite integral. By the way, observe this carefully. 2i can be written as half of integration from 0 to pi by 2. Now this is log of sine t plus log of sine of pi minus t, which is again sine t. Log of sine t plus log of sine t becomes 2 times log of sine t into dt minus, this is log 2 into, now in place of x we have to substitute first upper limit minus then lower limit. Now in next step I can write it as 2i is equal to, look at this now, this 2 and this 2 can be cancelled. So it becomes simply integration of log of sine t dt from 0 to pi by 2 minus, it becomes pi by 2 log 2. Now what remains is only the first integral. By the way, again I am applying one property here, and the property is integration of f of x dx for the limits a to b is same as integration of f of t dt for the limits a to b. That means if the functions are same, limits are same, only variable is different, then the integral remains same, integral value is same. So I can write this as integral from 0 to pi by 2 log of sin x dx minus this pi by 2 log 2 remains same. Now what to do with this first integral, yet it has not been solved. So if somebody observes this integration of log of sin x dx is here in the question itself, this is I. So if it is I, then in this step, I can replace the first integral by I, and it becomes then 2i is equal to I minus pi by 2 log 2. Now in next step, this I goes to left hand side and I get it as I is equal to minus pi by 2 log 2. So this is the value of I. That means this is the value of integral from 0 to pi by 2 log of sin x dx, or one can say this is integral from 0 to pi by 2 log of cos x dx. Both are equal to minus pi by 2 log 2. So this is the solution.